There are many separation techniques in chemistry because when we make a specific chemical, there are often undesired side products, or we might need a dry product that we made in a solution. Regardless of the reason, there are methods to separate gases, mixtures of two or more liquids like distilling gasoline into mineral spirits, and separating mixtures of liquids and solids. The basic method of separating a liquid solution from a solid is gravity filtration. This is what happens when you make coffee. A suspension of water and coffee grounds is made, flavor molecules and caffeine are dissolved in the water, and then the solution of coffee is separated from the used grounds by a coffee filter. The solution falls through the filter due to gravity, hence gravity filtration. Gravity filtration is convenient because it's simple to set up and easy to perform, but it can be really slow. One way to speed it up is to pull a vacuum on the receiving flask, which will cause air pressure to push the liquid down, greatly speeding things up. This is called a vacuum filtration. In this lab, we will be using a vacuum filtration to perform a gravimetric analysis in order to determine the concentration of an unknown solution using a precipitation reaction. For the discussion section of this lab, you'll tell me how gravimetric analysis works and how vacuum filtration works. I'll provide some sources, but you'll need to do some digging around for yourself as well. You should explain both concepts fully. You should cover how it works, why it works, when it would be useful, and when it would not be useful. The materials you'll need for this lab are a ceramic Buchner funnel. There are plastic ones, but they tend to be cheap and they'll usually let some material through. You'll also need a Venturi valve, a filter flask with a rubber hose, filter papers, a 50 milliliter graduated cylinder, and a 150 milliliter beaker. Sodium carbonate is used as the known chemical in this video, and barium chloride is used as the unknown, but the chemicals used might change. The process and the math will work the same way regardless of the chemicals used, but the molar masses would be different. For our procedure, our first step is to create a 2 molar solution of the known chemical by weighing out 0.1 moles of the chemical and dissolving it in 50 milliliters of water. In this case, that's 10.6 grams of sodium carbonate because sodium carbonate has a molar mass of 106. Once the chemical is fully dissolved, remove the stir bar and turn on the heat to medium. Then pour in 25 milliliters of your unknown solution. In a gravimetric analysis, the known chemical must be added in excess. And while it doesn't matter which one gets added to which, a common practice is to keep adding the known chemical until no more precipitate occurs. Heat the precipitate for about 10 minutes, placing a watch glass over the beaker so that no splatter occurs. We are heating the precipitate to increase the grain size of the solid so that it does not clog our filter. While the precipitate is heating, set up the Buchner funnel on the filter flask and weigh the filter paper. We will need to subtract the weight of the filter paper from our final product once we're ready. Hook the rubber hose up to the Venturi valve. This is a special valve that will pull air to create a vacuum in the filter flask. It screws into the faucet head easily. To place the filter into the Buchner funnel, place it flat, place it gently, and make sure it is precisely in the center. This is very important so that no gaps are created that would allow the precipitate to pass through. Using a spray bottle, wet the filter paper and turn on the faucet to provide the vacuum. The faucet will need to be turned up more than you would think. Once the filter is ready and is fully adhered to the Buchner funnel, begin pouring the precipitate into the funnel. Use a glass stir rod to direct the water towards the middle of the filter. Try to go as slow as you can to keep all of the solid pooled in the middle of the filter. If you fail to do that, it is salvageable, but your accuracy will suffer. You'll be able to see the water get pulled away from the solid. Once you've poured everything from the beaker into the funnel, use a wash bottle to get any remaining solid from the beaker and the stir rod. We want to try to get everything to make our final measurements as accurate as possible. If you weren't able to keep the precipitate in the middle of the funnel, use a spatula to scrape the solid away from the sides of the funnel and use a wash bottle to remove the precipitate from the spatula. Label a watch glass with your name, turn off the water, and pull the filter paper and precipitate out using the spatula. Place the watch glass in the drying oven overnight to remove any water. The next day, weigh the filter paper and precipitate. Subtract the weight of the filter paper and calculate the number of moles of product created using the coefficients of the reaction. Determine the starting number of moles of the unknown product and divide by 0.025 liters to determine the initial concentration. Now, considering this is your first gravimetric analysis, your results may be as low as 70% accurate without hurting your grade. Your final precipitate can be thrown away in the garbage. Everything else should be cleaned and put away before you move on.